Hi folks, we're going to take a look at number 6 from today's worksheet, and they're asking us to sketch two graphs of quadratic functions that are given in factored form. All right, so let's recall what factored form is particularly useful for, is because all the operations on the right-hand side of the equation are multiplications. It's very easy to determine when that's going to be equal to 0. In other words, it helps us find the x-intercepts, because when I've got 2 or 3 or 4 expressions that are multiplied and they equal to 0, means one of the expressions has to be equal to 0. So clearly here, this -1 in front can't be equal to 0. So the only options are that x minus 2 is equal to 0, or x minus 6 is equal to 0. All right, and in this case here, x is equal to 2 or x is equal to 6. All right, now you might recognize this straight from the general form of factored form of a quadratic. Okay, that x minus this number is automatically an x-intercept. X minus that other number will be another x-intercept. So you can just read off the equation that 2 and 6 are going to be an x-intercepts. But not a bad idea to get used to the idea as to why these numbers are x-intercepts. Okay, and it has to do with this idea that when I've got two things that multiply to 0, the only thing that can happen is that either one of them, or both, in this case here, one of them is going to be equal to 0. All right, so now that we've got the x-intercepts, we've got 2 points, but that's not really enough to graph the function, because it would be nice to know where the vertex is. And this is where we use the symmetry of the function, because if I've got these two x-intercepts at 2 and 6, well, because they're at the same y value, I know that the axis of symmetry is going to lie exactly between them. So in other words, it's going to be the average between those two. Okay, so my h value, which gives me the x value of the vertex, is just given by 2 plus 6 divided by 2, which is going to be equal to 6 plus 2 is 8, divided by 2 is 4. All right, and now if I want to find the y value of the vertex, I just have to input the x value into the equation. So let's see what we have. We have -4 minus 2 times 4 minus 6, and let's see what we have. So 4 minus 2 is 2. 4 minus 6 is -2. 2 times -2 is -4, plus we have the negative in front, so that's equal to 4. All right, and with these three pieces of information, in other words, the x-intercepts and the vertical asymptotes, that's enough information to draw a fairly nice graph. Okay, so once you have this information, what you definitely want to do is use a nice scale to draw this out. So I see that most of all my x values are on the positive side, so I'm going to draw my y axis further to the left. All right, and I see that my the y value of my vertex is at 4, and it's going to be going downwards because of the negative. Okay, so I'll put my x-axis maybe a little lower. Okay, so there's, say, is my x-axis. All right, there is my y-axis, and because the numbers are all fairly small, I can go up by 1, both on the x and y. All right, so now we can plot our x-intercepts. So our x-intercepts occur at 1, 2, and at 3, 4, 5, 6. So here are my x-intercepts, and my vertex occurs at 4, 4. So 4 and 1, 2, 3, 4. Okay, and then from here, of course, I can see it just by the picture, but I also know because of the negative a value that this is going to be a parabola going downwards. So we're going to try to carefully draw it so that it looks pretty symmetrical on either side. Not the nicest parabola, but it'll do. Okay, and that's a good enough graph here. All right, so let's take a look at the second one, and again, very similar. You know, we're looking for the x-intercepts, so we make the y value equal to 0. All right, and again, I've got the product of a bunch of expressions that equal to 0, so the only option is that one of these things has to be equal to 0. 3 can't be equal to 0, but x plus 4 certainly can. Okay, or x minus 3 can also be equal to 0. So what are my x-intercepts? -4 or 3. okay, which again, I could have read right off the equation because this is like x minus r, so x minus -4 is the same as x plus 4, so -4, then x minus s, my other value is 3. Okay, so now let's find the vertex. So the h value of the vertex, again, is just the average of the two. So -4 plus 3 is -1 divided by 2, so -0.5. And so here, in order to find the y value of the vertex, I just plug it into the equation. So 3 times -0.5 plus 4 times -0.5 minus 3. All right, so here, since we're working with numbers that are not quite as nice, let's use our calculator here. So we've got -0.5 plus 4, okay, equals 3.5 times, well, -0.5 minus 3 is -3.5, okay, and all that times 3, and we have -36.75. All right, so that's equal to -36.75. All right, so here I'm clearly going to choose a scale for my y value that doesn't go up by 1 like I did here. My x values are fine to go up by 1 because I'm going from -4 to 3 with -0.5 in the middle. But for this one here, I'm going to have to go up a little faster. All right, now because I know this is a parabola opening upwards, okay, I'm just going to worry as long as I can get as far down as 36.75. So let's say I want this to be -40, minus 35, 30, 25, 20, 25, 15, 10, 5, 0. Oh, there we go. So I can go up by 5s. All right, so let's go here. Let's get our x-axis here. Now let's take a look at our y-axis. Where should we put it? Well, somewhere down the middle because I'm going from -4 to 3, so I'll put it right down the middle here. And here I'm going to go up by 1 each time, but here I'm going to go up by 5. All right, so let's put our x-intercepts. Our x-intercepts occur at -1, 2, 3, 4. Okay, and at 3, 1, 2, 3. And now our vertex occurs at -0.5, so right here, and 5, 10, 15, 20, 25, 30, 35, 36.75 will just be a little smaller than that, so somewhere in that vicinity. All right, and now I can try to draw as nice a parabola as I can. Make sure it's nice and curvy at the bottom, not a pointy parabola. And there you have it. That's a pretty good parabola. All right, so just to recap, when you're given an equation in factored form, the easiest thing to determine first are the x-intercepts. All right, once you have the x-intercepts, you can use that to find the x value of the vertex. And once you have the x value of the vertex, you just input it into your equation to get the y value of the vertex. And then from there, the only other thing to be careful of is what you're choosing as your scale when you're drawing the graph. Okay, that's it for this one.